Hello, it's Dumplet here. Here's an item on summations. To evaluate this symmetric summation, 1 times 100 plus 2 times 99 plus 3 times 98 plus so on and so forth until the last term, 100 times 1. As usual, pause this video if you'd like to give this item a try, but if you're done, let us dive into the solution. Now, here we do have a symmetric summation, and we do notice kind of a pattern because, well, the numbers here, let's take a look at the left numbers. It's going to be 1, 2, 3, and I believe the next is going to be 4, 5, 6, all the way until 100. So that's a nice clue that we have 100 terms in this sequence. And the right number of each product, 100, 99, 98, it goes down. So at least we can describe the pattern. Now, usually whenever we have a summation like this, it would be very nice to write like the general term, let's just say the nth term. So it would be very nice for us to write this in sigma notation. Now, we have a sigma notation here. We know it's 100 terms. Let's just say it's from n equals 1 until until 100. So hopefully we can write this in, we can write a general formula for the nth term. Now, we can do some observation. Well, obviously the right numbers, the left numbers are already 1, 2, 3, and so on. That kind of indicates the nth term. So I think for the blue terms, I can just represent it as n. And then for the green terms, well, it's going down each by 1. So I think I can write the green terms like this. So 101 minus n. Because the numbers go down 1 by 1, so it's kind of linear, right? So we subtract 1 for each succeeding term, so I can write it as 101 minus n. So if n equals 1, that's 100. If n equals 2, that's going to be 99, 3, 4, 98, and so on. All right, and that's how we represent a sum. And at least we have a very nice general formula for this one, so we can work with that. Because now that we have, so essentially we just want to find for this one. Now, we can try to manipulate, you can try to use the fact that we have a nice formula for this one. That's going to be equal to 101n minus n squared. And essentially, we're just doing this summation from n equals 1 to 100. So essentially, I have the following addends. So the first term is 101 times 1 minus 1 squared, right? Plus 101 times 2 minus 2 squared. 101 times 3 minus 3 squared, and so on and so forth until the 100th term. So 101 times 100, 101 times 100 minus 100 squared. All right, so essentially speaking, we can kind of see here that, well, 101 minus 101 times 1 plus 101 times 2 plus 101 times 3, so on and so forth until 101 times 100. We can write this as 101 times the sum of 1, 2, 3, all the way up until 100. Next, for the minus 1 squared, minus 2 squared, minus 3 squared up to minus 100 squared, I can represent this as minus, so the sum of the first 100 positive perfect squares. Now, because this and this have very nice closed forms, or there's a formula for these two, so it would be easier for us to get the sum because of a nice representation. All right, so let's take a look at these two. So the blue one, the sum of the first n positive integers has a very nice form, n times n plus 1 divided by 2. For the sum of the first n positive perfect squares, it is n times n plus 1 times 2n plus 1 divided by 6. That's the closed form. So essentially, we just have to substitute n equals 100 for both. So the first one becomes 101 times 100 times 101 divided by 2. Right? That's for the first one. And then for the second one, it's going to become minus, and then 100 times 101 times 201 divided by 6. Whoops, divided by 6. All right, so for the first one, you guys can work out the math. That would be equal to 101 squared. So 101 squared times 50. So 101 times 101 times 50, that's going to give us 510,050. Now, for the green term, it's going to be 100. Just simply, we can cancel the two. We can cancel some things out here. So the 100 and the 6, so it's going to be 50 and then 3. And then the 3 and the 2, 1 cancels nicely, so it's 67 for this one. So I can essentially do 50 times 101 times 67. And that's going to give me 338,350. So the numbers are a little bit big, but you guys can work out the arithmetic. If we work out this, we are going to get that the initial summation, the initial symmetric summation, would be equal to 171,700, right? And this will be our final answer. Hopefully you guys learned something new from this video, and I'll see you in the next one. Bye bye.